divide everything by 196, okay? Now what happens if you divide everything by 196? What do you notice? Anything that's reducible? 49 over 196. Is that reducible? Calculator. Yeah, check it out.
Yeah, by 4.
By 4, right?
1 over.
Yeah, you got? This one, what about this one here? Reduced by 4, then that'll be what? 49, right? So this one is written as x squared over 4 minus y squared over 49. And what is that equal to?
Equal to 1.
1. Now, what do you notice? Is that equation in hyperbola? So now, can you tell me about the center of this hyperbola? Okay, so just compare that form. So what happens if that h and k, if they're not shown? Well, that one's out better.
This one is like stopped because they put it in the wrong one.
Oh, let me see. I'll just save this one first. Okay, so now h and k.
0.
0, 0. What else do we know? A squared. So what would be the value of a squared?
The value of A
Well, a squared first.
is 4.
A squared is 4. So that means a, which is
2.
2. B squared,
49.
49. And then b,
7.
7. Okay, so we found so far. Okay. So now we do have a center. And now the next thing that we want to find out, the vertices. And how do you find the vertices for this? Well, it's all about the type of the hyperbola. So what type of hyperbola is this? Horizontal or vertical?
How do we tell?
How do you tell? Which one goes first?
Oh,
X goes first, right?
horizontal.
If X goes first, what kind of hyperbola is that?
Horizontal.
Horizontal. What happens if Y goes first? Then that'll be vertical, right? For the hyperbola. So the way to find the vertices, the formula for that is what? H plus A, comma K. And what else? H minus A, comma K. Right? So H, what we got is 0, so 0 plus 2, so it's 2 comma to 0. And then the other one here, what is that? Negative 2, comma, 0. Because that's what? Symmetrical, right? So now let's plot the point here first. So started at 0, 0 for the center. 1, 2, 1, 2. Is that what we got so far? Now, you might be wondering, how do we find the asymptote here? Well, there are two different ways we can find asymptote. We can use the formula for that, or we can just set up the imaginary box, the imaginary rectangular box. Okay? So now, what's the value of b right here?
7.
7. So you ready for this? So if that's 7 from the center, so we count it, 7 units up. Okay, right here. And then down here, 7 units. 1, 2, 3, 4, 5, 6, 7. Now this one, they're not considered covertices. They're just like the margin, the distance for the box, the rectangular, the imaginary rectangular box. So try to connect this. Okay, so the vertex, and then the one that we find out with the value b. So try to set up the imaginary box here. Okay, what do you notice about the corner? Can we just connect those points from the corner to corner? What happens if I try to connect all this point here? This one's kind of like a rise over run. right? Rise over run. If I try to connect them, what does that tell you?
Diagonal.
The horizontal, what do you call that? Horizontal asymptote. Well, I mean, not the horizontal, the slant asymptote.
Yeah.
The slant asymptote. So another way that I can find the slant asymptote for this one, again, what kind of hyperbola is this? Horizontal, right? So the way to find out the slant asymptote for this one, it's always y minus k. So that equals, well, this one is b over a. So plus minus b over a, x minus h. Like that. Alright? It is, right? What's h and k? 0, 0. Just plug in a number. B over a, what's b? 7. A, 2. So plus minus 7 over 2, x. So that means y equals plus minus 7 half x. This slant asymptotes. It is, right? You guys see that y-intercept started at 0, 0. Rise over run, up 7, 2 over to the left. Or up 7, 2 units to the right. Or it could be down 7, 2 units to the left, down 7, 2 units to the right. So now, what happened to the points? Just make the parabola. And you might be wondering why it's so stretching here. Why? How come it's so narrow? Because the what? The slant asymptote. The boundary. And also it shows that the value of b and a, the ratio. So this would be the hyperbola. And now, what about the foci? How do you find the foci? If that's considered horizontal,
H plus C.
so h plus, wait, c, right?
Yeah.
We haven't found c yet. How do you find c?
Square root of
Square root of a squared plus b squared. Okay, let's find c first. So c equals what? Square root of 4 plus 49, which is it's a non-perfect square number, right? Now let's find out what that is on your calculator. What's square root of 53? So what is that about? Okay,
7.3.
what is it? 11.3? 7.3? It is, right? Pretty close. So 7.3, so count it from the center. So 7.3 units to the left. And then 7 units to the right. So 1, 2, 3, 4, 5, 6, 7. 0.3. So here's the foci. One of them. And then over here count it. 1, 2, 3, 4, 5, 6, 7. 0.3. So this one is considered root 53, comma, 0. And this one is negative root 53, comma, 0. Yes? Does that make sense? Hyperbola. So for the hyperbola, it's not just finding the center, the vertices, but also the foci, and more importantly, the slant asymptotes. So this one's for horizontal. Any questions? Yeah, Tika? TT? Now let's do the one with vertical. Okay? So let's do the one for, let's do B. Do not worry about eccentricity for this one, okay? Eccentricity, this one it's always greater than 1 because it's a wide range of hyperbola. Okay, so now let's try B and see what happened. So what do you think that hyperbola? What kind of hyperbola is that? Horizontal or vertical?
Vertical.
Vertical. Why is being vertical?
Because y goes first.
Y goes first. Okay? Again, identifying the value of A, B, and C. Then the center, and also find the slant asymptotes. Okay? For B. So the one that we just drew right here, so let's say that this one is the cross sections. If that's three-dimensional, what do you notice? So it's kind of be like this figure here. Kind of like a bit of an apple, right? Yeah? Like a narrow. So it's kind of like a cylinder is being cut.
How do you know?
How do I know?
Yeah.
Well, again, the way that we did it, because that's two-dimensional, so that one is just like a cross sections. But I try to make it three-dimensional. So what happens if you just revolve this figure around the y-axis? Would that be a three-dimensional? So normally that's kind of like a cylinder, but the things that the sides has been cut, right? So
You wouldn't have to graph it like this, right?
no, you don't.
Oh,
No, just the cross section, not 3D. Okay, if that's 3D, then that would be multivariable calculus. Okay, don't worry about that. Okay, so now try the next one and see what happens. Again, identify the center, vertices, foci, and then find the slant asymptote, if that's possible. Okay, so here's what we got. Okay, Tika, can you tell me about the center for this? -1, comma 0 or 0, comma -1? The other way around, right? Because that h is always right next to the independent variable. And then the dt, the value of a squared.
A squared?
Mm-hmm. 9. So that means a is 3, right? B squared, that one's pretty obvious. 25. So b is 5. So now, Katika, how do you find the value of c?
3 squared plus 5 squared, and then the square root of that.
Okay. So basically just what? Square root of 9 plus 25, which is what? Square root of 34. Again, it's a non-perfect square number, so this one I would like to round it to 1 decimal place. So let's find out what that is on your TI 83.
5.8.
5.8. All right. So now we found the center, so let's find the vertices. Now we do know that it's a vertical hyperbola. So for the vertices, then that would be considered what? H, comma, k plus a, right? Yeah? And then what else?
H comma k minus a.
Wait, hold on a second. This one is it's a vertical. So that's vertical. So instead of using a, we're using what? We're using b, right? Well, a is, because this one is for, well, let's see, hold on a second. No, that's right, that's right. I was thinking about like ellipse. Yeah, that's right. Okay, it's always a. So now, what is it? So h, which is what, 0? So k plus a, so -1 plus 3.
2.
2. And then 0, k minus a,
0 comma
-1 minus 3, which is
-4.
-4. Again, so they're kind of symmetrical there, okay? Because the center. Okay, so now let's plot the point first. So we got 0, -1, the center. And then what else do we have? 0, 2. So one of those vertices. 1, 2. And then the other one is 0, negative 4, negative 1, negative 2, negative 3, negative 4. You guys see that? Equidistant, right? Yeah. Now, here's the problem. How do we find the slant asymptote for this? It's a vertical.
Do they all have slant asymptotes?
Yes, always, if that's a hyperbola. Okay, so now since we do know the vertices right here, so now what's the value of B?
5.
5. Guess what? From the center, so you want to count it, 5 units to the right. And then from the center again, 5 units to the left. Well, basically we just want to find out the endpoint for the imaginary box, right? The endpoints for the imaginary box. So you see that it's a rectangular imaginary box right here. Once you connect those endpoints. Okay, so 5 units to the right, 5 units to the left. So what should I do with those corner points? Would that be considered the slant asymptote? Yeah? Maybe try to connect them from one corner to another corner through the center. We try to connect this all together. Extend it. Yes. So for the vertical hyperbola, the way to find the slant asymptote. So here's the one. So it's y minus k once again. Over here, x minus h. But then the slope is going to be a little bit different. The slope, the previous one, that was what? The previous one, that was b over a, right? But now this one would be considered a over b. That's a vertical hyperbola. Well, let's just confirm that it's correct. So y minus k, what's k? What's the value of k right here?
Negative 1.
-1. Plus 1, right? A over b. So 3 over 5. Rise over run. X minus h. What's h? 0, right?
0.
You guys see that? And then solve for y in terms of x. So plus minus 3/5 x minus 1. You just check that. Would that be the slant asymptote? Right, eh? Yes, right? Check that. -1, the y-intercept, right? And then what else? Up 3, 5 over to the right. We're down 3, 5 over to the left. We're down 3, 5 over to the right. See that? Rise over run. Okay, y-intercept, -1, down 3, 5 over to the right. We're up 3, 5 over to the left. And the other line here, same y-intercept, up 3, 5 over to the right. We're down 3, 5 over to the left. Formula that we have. Again, the way to find the slant asymptote for the vertical hyperbola. So it doesn't matter what kind of hyperbola that we have, so just follow through the structure. Okay? The formula. The center, the way to find the foci. Oh, we need to find the foci. So what are those two? So what are the foci? So h comma k plus c, right? And then h comma k minus c. So what is it? So 0, 2 plus 5.8, which is what, 7.8? And then 0, k, so which is what? -1? Wait, hold on a
Why are
second.
you using 2?
Wait, no. We're using what? K, right? So -1 plus 5.8, so it's 4.8. And then the other one, what is that? -1 minus 5.8, -6.8. Is that right? So 0, 4.8. And then the other one, what is that? 0, -6.8. Somewhere over here. Again, they're all symmetrical. So now, what do you notice? There's going to be two parabolas, right? One is facing upward, the other one is facing downward. Like that, right? And here's another one. Hyperbola. Yes? What do you think? Okay? So again, the center, the vertices, the foci, and also the slant asymptotes. So what do you think the eccentricity is? Would that be less than 1? Greater than 1? Because we do know that ellipse, eccentricity is always less than 1, right? It's just the ratio of the roundness of the circle, the circular figure. What do you think about this? Should be greater than 1, right?
Greater than, yeah.
Greater than 1. Yeah, eccentricity. So the way to find eccentricity for this one, so let's see. Is that going to be A over C or B over C? It's going to be the other way around. The C is the greatest value. So eccentricity for this one, it's about C over A. Right? C over A. Well, let's find out. Is that greater than 1? 5.8 over 3. It is greater than 1, right? So what is it? Yeah, just find out what that is on the calculator. 5.8 divided by 3, it's about like 1 point something, right?
Yeah, 1.9.
1.9?
1.93.
1.93. So what do you think? Hyperbola? They're quite similar, right? Ellipse, hyperbola, and then the other one circle. Well, circle is a little bit unique, you know, without the denominator, and the radius is always isolated on the other side. Okay? So now, let's see what else I'd like to do. So for C, that one just completing the square, you can do it later. Now, let's try the one that's a little bit difficult. Can you guys do 2B? So write an equation of the hyperbola with the following characteristics. So the vertices plus minus 11, 8. Asymptote, that's given already. It's y equals plus minus a over 11, x plus 8. Okay? So how do you write an equation of this hyperbola? I mean, you can plot the point first. You can set up the slant asymptotes on the graph and then figure out the value of A, B, the center, things like that. Keep that in mind. The center, it's always the point where those slant asymptotes intersect. Right? See that? Slant asymptotes. The point where they intersect, it's always the what? The center. Okay, so let's find out the center. And then from the vertices, so we can determine the equation of the hyperbola. Okay, so here's what we got in the given. So what are those two slant asymptotes here? Well, here's what we got for the vertices, and asymptotes we have plus minus a over 11x, and then plus 8. So anything that we should start at first? Should we find the center? Now, how do you find the center? Anyone? Any thought? You guys see that right here? The asymptotes? That's the point where they intersect, right? So what should I do with the equation? So that means a11x plus 8 is the same as what? Negative a over 11 x plus 8, right? Because we want to find out the point where they intersect. Hey, what do you notice? What happened to 8? Can we cancel them out? So a over 11x equals negative a over 11x. So bring everything together to one side. Like that, right? So this one we got 16 over 11 x equals 0. So what's the value of x? 0. So what would be the value for y then? Plug in a number, back to the original equation, right? So we got 0 plus 8, which is what? 8. So the center, 0, 8. Okay? So we found the center. So now compare and contrast. What kind of hyperbola is this? Here's the center. Here are the vertices. Now you see that we don't change the k value? We don't change the value of y, right? So what kind of hyperbola is that? Horizontal. It is, right? Because the vertices is right along the what? The x-axis. The horizontal x-axis. So we got a center. Can we figure out the value of a? So what do you think the value of a is? 11. Right? The value of a, that's 11. Do we know the value of b?
Wait. No, wait. Doesn't the equation have like a over b or something?
A over b?
Or b over a.
Right. Remember, the slope here, what does that tell you? Rise over run. Again, what kind of hyperbola is this? Horizontal, right? How do you find the slant asymptote for the horizontal hyperbola? Y minus k equals plus minus b over a x minus h, right? Just compare the slope. What's the slope here? B over a. What is that equal to? A over 11. Well, we found a already, so what's the value of b? 8. Right, Yutika? Yeah? Again, it's all about the comparison. So this one is for the horizontal hyperbola. And that's just the slant asymptote formula. So now we got A, we got B, we got the vertices. So now can we write equation of this hyperbola? X minus h quantity squared over a squared, right? Okay, let's do it. Okay, this one. So once we do have all the informations, A, B, H, and K. So basically we can set up the hyperbola. So it's x minus 0 quantity squared over 11 squared minus y minus k. So y minus a quantity squared over b squared, a squared. So the whole thing, what is that equal to? 1. And then you try to simplify the equation a little bit. X squared over 121 minus y minus a quantity squared over 64. And what is that equal to? 1. What do you think? All right? Yeah? Okay, so now let's see what else we have. Would you like to try the next one? 2C? Again, so just plot the point and try to figure out the value of A, B, and then the center. So once you get that, all the information, again, so just set up the equation of the hyperbola. So try 2C for the next 5 minutes. Okay? Did you guys do any conics yet? No? No? You did?
Wait.
No, in
What
pre-cal.
are conics? Like,
In your regular class.
well, like what do we solve in conics?
Conics, like completing square, finding equations, like what we were doing. Graphing? No?
I think a little bit.
A little
from,
bit?
From a graph. Like,
From the graph? Okay,
yeah.
cool. Like circle, ellipsis?
No.
No? Just basic parabola?
Not basic parabola, but like to degree like up to like maybe 6. You wouldn't
Okay.
have like a super long one, but
Uh-huh.
yeah.
Okay. Yeah, so try 2C and see what happens. Your teacher probably saved this one for the last, for pre-cal. Okay, so here's what we got. Again, if you're not quite sure what to do, so just plot the point. So try to set up the rectangle, the imaginary box for the hyperbola. And then from there you can figure out the length, the width, so that basically tells you the value of A and B. See for that one. So for 2C, so 4 comma 15 and 4 comma 1. So just by looking at the the vertices, excuse me. So what kind of hyperbola is that? See that the value of x, we don't change the value of x. So it's going to be what? Vertical, right? Vertical. Another thing is that since we do know the vertices, they're considered symmetrical, can we use the midpoint formula to find the value of k?
Yeah.
Yeah? What's the midpoint formula again?
X.
y1 plus y2 plus x1 plus x2 comma over 2 comma y1 plus y2 over 2, right? Well, this one there's no need to find the x value for the center, just the value of what?
K will be 8.
Yeah. Combine them, divided by 2, which is what? 8. So that's the value of k. So the value of h, that's given already. Right? So h comma k. So we found it already. So now, what else do we know? The perimeter of the rectangle. Okay, so now let's just set up the basic points. So we got 4 comma 15. (12, 13, 14, 15), all the way up here. And then the other one is what? 4 comma 1. Center, we got 4 comma 8. Is that right? So we do know that the box is going to be like this somewhere around. Now, what do you notice about the height of this box?
It's 16.
16. And what's the given perimeter of this box?
72.
72.
So we have
How do you find the width? We got a height already. How do you find out the
72
width?
minus 32 divided by 2.
Yes, so 72 minus 16 divided by 2.
No, minus 16.
Just minus 16, then that's the width, right? And then once you divide it by 2, that means we want to find the other value, the other component. So subtract, which is, well, divided by 2 first. Which is that 20?
Yeah.
Yeah? So the width is what, 20? So we got a height, we got a width. What's half of distance of the height? Wait, oh, 8, that's the height. Okay, what about the width? 10. Why do I divide it by 2?
Wait, if it goes from 4:1 to 4:15, isn't the height 14, not 16?
Wait a minute.
Oh, yeah.
Yeah, the height's not 16, right?
Okay. Yeah.
The height's supposed to be
14.
14. 7 plus 7. Thank you. Okay, so 14. So that means it's what, 36 minus 14? Well, still consider even number. And that's pretty easy to deal with. So what's the distance of the width? 22, right? So half of 22? 11. Yes? So now keep that in mind. The center is what? 4, 8. And then this one, what is that? That's the vertex. So this one is written as h, comma, k plus a. So what's the value of a here? Oh, this one's 4, 8. This one's 4, 15. Excuse me. So what's the value of a?
Okay.
Well, because this one is the center. This one is the vertex. So what's the value of a right here? 15 minus 8? 7. And what's the value of b? What's half of 22? 11. You guys see that? By using the perimeter. So we got a center, we got a value of a and b. What can we do? Write the equation of the hyperbola, right? Again, what kind of hyperbola is this?
Vertical.
Vertical. So that means it's what? Y minus 8, comment, well, y minus 8 quantity square over a square. So it's 49 minus, and then x minus h. So x minus 4 quantity square all over 11 square, right? Yeah. And what does that equal to? What do you think? Okay? Yeah. So this one you need to do some kind of analysis. So using whatever the given element we have, and then from there analyze it and try to figure out the rest of the unknown. Any questions? Okay. So now let's see. You guys just flip that to the next page. Well, the next one is just like graphing. So let's do one more and then we'll take a break. So let's do the one that we have to complete the square and then try to figure out the value of the center, the vertices, the foci, the slant asymptote. So now, can you guys do the review for 9.1 to 9.3, 2c? Okay, so negative 9x squared. That one looks a little bit intense. Okay, let's try that one. So for this one, we do have negative 9x squared plus 16y squared plus 54x plus 64y minus 161 equals 0. So graph the following conic sections. So what kind of hyperbola is that? Just by looking at the equation without doing anything. Would that be considered horizontal or vertical? Because that started with negative 9x squared.
So horizontal?
No,
No.
it's vertical. Because that normally for the variable, you always want to start with the positive variable. The positive and behavior variable, which is what y squared. So that's when you want to swap the terms. Where you want to group the like terms. So group like terms. So 16y squared plus 64y, parentheses, and then minus 9x squared. So at the same time, I take out negative, the negative 1. So minus 54x, and then 161, negative 161, you can just take that to the right hand side. So just remove that negative 161. So group the like term and isolate the constant term. Okay? Yeah? So now, what do you notice? Can we take out the greatest common factor here? Yeah? So the first group, what's the greatest common factor? 16. No, just 16. Y squared, because we want to complete the square for this. So we got y squared plus 4y plus blank. And now, what about the second group? Greatest common factor? 9. So x squared minus 6x plus blank. Okay, so we took out GCF. So how do you find out the number for the blank? So what is that magic formula again? B over 2 quantity squared. So 4 over 2 quantity squared, so 4. And then over here, do the same thing. Which is what, 9? Yeah? Do you guys all agree?
Yeah.
Now, what happened on the right hand side? What do we need to add for those two blanks?
Add 81.
Gotta be careful with this.
Or
So this one, so the number we're adding here, it's not just 4, right? It's 16 and 4. 16, the product of 16 and 4. So we're adding 64. And what about for the second blank?
Subtracting 81.
Subtract 81. Right? Katika? Mm-hmm. So now what we got here is 16. So y plus 2 quantity squared minus 9 times x minus 3 quantity squared. So what's 161 plus 64? Minus 81. Oh, let's see. So this one is 161 minus what? 17? Yeah? Which is PT, what did you come up with that?
144.
144? Yeah, that's all we got. Now, what's next? How do we convert that 144 to 1? Divide everything by 144. $16 over 144, is that reducible? It is, right? Is that 9? Yeah. So we got y plus 2 quantity squared over 9. And then over here, we do have x minus 3 quantity squared over 16. And that equals 1. That's the equation of the hyperbola. So far, that's just the first step, right? We just found the equation. Guess what you have to do? Graph. So identifying the center, the vertices, the foci, and then the slant asymptotes, and then sketch the graph. Okay? It is a lot of work. Yeah, it's very intense. So what kind of hyperbola is this one again? Horizontal or vertical? Vertical. And why is vertical again? Because we started with what? Y first, right? Yeah. So we just complete the square and found equations. So now let's sketch the graph. So let's start it off with the center, which is 3 comma negative 2. Vertices. Well, a squared. What's the value of a squared here?
9.
9. So that means a, which is 3. B squared. 16. So b is what? 4. And then c, square root a squared plus b squared. 5. Okay. So now, what are the vertices here? We do know that's a vertical hyperbola. So that means 3 comma negative 2 plus 3. Negative, well, positive 1, right? And then what else? 3 comma negative 2 minus 3. Negative 5. Vertices, right? Foci. So what are those two focuses? It's also what? 3?
Negative 3.
But it's negative 3. Because that's what? Negative 2 plus 5. Well, positive 3, right?
Oh, yeah.
And then 3 comma negative 2 minus 5, negative 7. Okay, so now let's plot the points. So 3 comma negative 2, 3, 1, 3 comma negative 5, and then 3, 3, and then 3 comma negative 7. So here's the center. And what's the value of b again?
4.
4. So that means from the center, you want to count it 4 units to the left, right? So 1, 2, 3, 4. And then 4 units to the right. 1, 2, 3, 4. Because we want to set up the imaginary box. So the vertices extended all the way to the value of b. Like that. Again, the corner spot, you want to connect it because those are the asymptotes. Okay, one's going this way, and the other one is going the opposite direction. So now, from the center, no, from the vertices, so what can I do? Just make the parabola, right? One is upside down. And then the other one is just like a normal. And make sure that the slant asymptote going to be straight. Is that what we found? Yeah? So anytime that you deal with this, the value b is very important because that either showing the width of the imaginary box or showing the what? The height. Right? Okay. Yeah. Okay, so now at this moment, I would like to take 5 minutes break, and then after that, we're going to be doing something else.